Hey, and welcome to the last part of Kubernetes security challenges provided by the learning platform called KodeKloud. This is challenge number 4. And we have a number of Kubernetes objects created inside the Omega, Citadel, and Eden Prime namespaces. However, there are several suspicious abnormal operations that have been observed in these namespaces. For an example, in the Citadel namespace, the application called web-app-caller is constantly changing. And we can see this for ourselves by clicking on the Citadel web app link, which is located down below here on the right. And refreshing the page every 30 seconds. Similarly, there are other issues with several other objects in other namespaces. Let's click on the link. So I'm guessing this color should be changing approximately every 30 seconds. And we'll check on that a little bit later. So to understand what's causing these anomalies, we are required to configure auditing in Kubernetes and make use of the Falco tool. Once done, we should click on the check button to validate our work, which is what we're going to do now, just to get a little bit better visual representation of the tasks that need to be completed for this challenge to be successful. Okay, so in Citadel namespace, we have some kind of instruction. So we should delete the role causing the constant deletion and creation of the config maps and pods in this namespace. Role and role binding that's causing this constant deletion of these two objects. We should not be deleting any other role or role binding. Okay. I'm going to check on these pods and config maps to see what's really going on. Let's observe them a little bit. And also the color changed from red to navy blue, I guess. So as we can see, we have a pod named web-app-caller in the namespace of Citadel that's been running for some time. And then approximately every 20 seconds, it gets terminated and then recreated again. And this is just running in cycles, keeps repeating. And the same goes for the web app config map, both located in the Citadel namespace. All right. So what we want to do right now, I'm guessing we'll have to set up an audit policy that should give us some clues on what's causing this deletion and creation of these two objects that we inspected just a little bit before. Okay, so the audit policy file should be stored at this path, and we're going to edit it. Then we're going to create this audit policy file. Then we're going to edit the kube-apiserver's specs a little bit. Just going to create a backup of the kube-apiserver just in case. If we mess something up, it's always good to have one. So let's create the audit policy file first. I'm going to use this minimal audit policy file. to log all the requests at the metadata level. So what we need to do, what this task requires from us, is to create a single rule in the audit policy that will record the events for the two objects, which are pods and config maps, depicting abnormal behavior in the Citadel namespace. This rule should, however, be applied to all three namespaces, so we'll expand this a little bit, shown in the diagram at the metadata level, as we already have. We should then also omit the request received stage. All right, so let's add some things to this audit policy. Could add namespaces. I'm just going to type them out. Save myself some time. This. Next is resources. Let's use this. And the resources are, as we already established earlier, config maps and pods. As for our last request, we should omit the request received stage. Let's copy this a little bit. Like this. Let me just check this. Should be fine. Okay, so next we should be editing the kube-apiserver. Like this. We need to add the audit file, audit log path, and also the audit file path first. And let's look for the audit log path. Let's copy this bit. Okay. So next we need to use a volume called audit that will mount only the file audit policy YAML from the control plane inside the API server pod in a read-only mode. So we'll create a we'll be adding the volume. I'll start with host path configuration. Should be using set paste for this. The paths are fine. Okay. So let's move to the volume mount section. And mount these volumes. to the kube-apiserver pod. The audit mount path should be in a read-only mode, which is set to true, so that's fine. And the paths are correct. Good. I think this should be it. Let's save this. Let's restart kubelet. And there it is. The kube-apiserver came back online. Let's check if our work was done correctly, and it was. Oh. kube-apiserver should be running, so let's validate our work so far once again. There we go. Okay, let's move on to the Falco section. We should install the Falco utility on the control plane node and start it as a systemd service. For that, I'm not going to use the official documentation because there are some problems, because the official documentation from the falco.org website was updated and it's not working correctly. It doesn't install correctly under this environment. There are some driver issues and I don't want to lose too much time troubleshooting that because we are actually limited by our remaining time. That's why I'll be using the documentation of how to install Falco as a package from the KodeKloud GitHub repository. So, short on Falco, it's what Falco is basically. It's an open source behavioral activity monitoring tool. It's been designed to detect and alert on abnormal activity in Linux containers, Kubernetes, and other cloud native environments. There we go. Let's start the service. And it's up and running. So what we should do next is configure Falco to save the event output to this file location. So we're going to edit falco.yaml for that. Let's enable the file output. And let's set the correct output. Before I leave, I'm actually going to check for syslog output. It's enabled. Right. We should be restarting Falco for these changes to apply. Let's check our progress while we're at that. Good. Another task covered. So now we should inspect the API server audit logs and identify the user responsible for the behavior, abnormal behavior in the Citadel namespace. And we should also inspect the Falco logs and identify the pod that has events generated because of the packages being updated on it. We should save the namespace and the pod name in the file opt compromise pods. Comma separated, namespace first, then followed by the pod name. Okay, so we can check Falco logs for that. We could check it like this. Or we can do, there's a bunch of different ways on how to do that. We could also do them, we can also inspect them like this. And what we can do now is grab this container name, as we're looking for event generated because of packages being updated on it, which is this event. And we can use recuttle for this. And the container ID. We can grab onto the pod ID and we'll get the name of the container of the pod and also the namespace. So let's pass that to the OPT compromise pods location in a format of namespace first, followed by the pod name. For some reason, I'm having some issues with copy pasting. There we go. Let's check our task. There we go. We got another check mark. So now we're inspecting the API server audit log, and we should be able to identify the user responsible for the abnormal behavior. We should be saving the user role and role binding responsible for the event to the file located here, comma separated and in the specific order. Okay, so let's check this log. We could grab it a little bit. So we need to identify the user in the citadel namespace. What we could do is perhaps use a JQ. Actually, so the purpose of this task is to identify the user responsible for the abnormal behavior. So this audit log records all the requests made to the Kubernetes API server, including the user, request type, resource, and so on. My approach here will be, I'll try to add a filter or two and see if I can get the if I can identify the user. that's responsible for this behavior. So this first filter selects all the events that occurred in the Citadel namespace. So this filter is applied using the select function and this condition. And the second filter could use that. All right. So the second filter selects all the events that were not generated by the Kubernetes control plane nodes, as we can see here. This expression will basically select all the elements in JSON data structure, where the username property in the user object is not a system node control plane. The select function is used to filter the elements based on this condition. I hope this makes sense. So what we have in front of us is this log. It's basically an audit event recorded by Kubernetes, and it describes a create operation on a pod named web app caller in the namespace of Citadel. And this operation was performed by the Kubernetes username Kubernetes admin. That was impersonating Agent Smith. So Kubernetes admin is being part of System Masters and System Authenticated group. And the user, Agent Smith, is a part of System Authenticated group. And this is how we got the user that was causing these issues in this Kubernetes cluster. Okay. We should now save the user role and role binding, which, by the way, we have here. Let's do this now. and the role binding. And save it to this location. Okay. Now all we have to do is delete the role and the role binding. There we go. We should also be deleting the pod belonging to Eden Prime namespace that was flagged in the security report before. Like this. And now this challenge should be solved correctly. There we go. Thanks for watching this series. If there's any question, you can leave a comment below. I had plenty of fun solving this, and let's hope that we'll get some more challenges in the future. So thank you for watching this again, and goodbye until next time. Bye.